Hello everyone, my name is Ankit Nanwal and today we will be starting with a new topic that is influence line diagram and rolling load. So basically what is influence line diagram and why we are making it, we will be discussing that. So first of all, you guys know that there are two types of loading on the structure. One is dead load and one is live load. Okay, so dead load and one is live load. So what is dead load? Dead load is the load which is stationary, eh? And it does not changes its position throughout the working life of the structure. Okay, so throughout the working life of the structure it does not changes its position, and live load can change its position during the working life of the structure. That is all about the loading condition. Okay, so what is the example of dead load? Dead load examples are self weight of the structure and flooring, etc. You can say that structure part that does not changes its position, self weight including all the uh, framework of the structure. We are saying that is including the self weight of the structure, that is included in dead load. But in case of live load, we can say when there are some passengers or wheel loads that are moving on the structure, that type of loading is moving loads, and you can term them as the live load. Okay, so these are the most common loads acting on the structure. One is dead load and live load. So dead loads are those loads which are stationary and do not changes their position throughout the working life of the structure. For example, self weight and flooring. But live load changes their position during the working life of the structure. Okay. Example, wheel loads and weight of the passengers. So in strength of material, you have learned about the making of shear force bending moment diagram of the structure when we are saying it is having dead load of 5 kilonewton that is acting on the beam. Okay. Now when we are talking about live load, we need to make a influence line diagram for their study. So how we will make the influence line diagram, we will be discussing that. We need to study that how we will be making influence line diagram for the reactions of the structure, how we will be making influence line diagram for the shear force of the structure, and how we will be making the ILD of the bending moment diagram of the structure. Okay, so these all parts will be divided. First of all, we will be learning about the ILD for reaction, then we will be going to ILD for shear force, and then we will be going to ILD for the bending moment. Okay, so you have already studied about making shear force and bending moment diagram. In that, you know there are three equations for that you have studied, that is summation fx equal to 0, one is summation fy equal to 0, and other one is summation mz equal to 0. So these three are the equilibrium equation you need to follow here also. Now when you want to make influence line diagram for any structure, so what are the steps involved in that, I will be discussing them. When you are making this influence line diagram for the simply supported beam, what you will do, take a simply supported beam here, and this is point A, this is point B. Okay, so for making influence line diagram of the reaction, so what are the reaction at these points? There will be two reaction, one is Ra, one is Ha. Here it will be Rb. Now we need to make influence line diagram for the reaction. So for the first of all, we need to move a unit load from A point to B point. So you need to first of all consider a section here. So I have considered a section here at this point. Suppose this is x-axis, and let this distance be A from here. Remaining distance will be L minus A, as capital L be the span of the beam. Okay, now you, for making the influence line diagram, you have to move a unit load, that is 1 kilonewton load, from this point to this point. Let this point be C here. So suppose this unit load has come here, that is 1, that is at a distance x. Okay, Now for making the influence line diagram, there is nothing but simply apply the basic concept of making shear force and bending moment diagram. You need to apply the equilibrium equation, that is summation fx equal to 0. Okay, for that will give you ha equal to 0. Second equation is summation fy equal to 0. Okay, by that you will get the value of Ra plus Rb equal to 1. Okay, now from the third equation, that is summation moment at A equal to 0. If I am taking moment at A0, there can be two cases. When I am making a ILD, suppose I am saying I want to make a ILD for RB. Okay, when I am making a ILD for RB, this point, then you need to consider moment at A to be 0. Okay, and when I am saying I want to make a ILD for RA, then you need to take moment at B0. Okay, this you need to remember. Okay, so now I will be making this point ILD for RB. So summation moment at A equal to 0. So when you are taking moment at A 0, so equation will be RB into L. Okay, this will give anti-clockwise moments. So I am taking anti-clockwise positive, then clockwise will be negative. So this unit load will give clockwise moment, that will be 1 into x, that is equal to 0. From here I will get the value of RB as x upon L. And now when I am making ILD for RA, for that I have to consider summation moment at B to be 0. Okay, now when moment at B will be 0, the equation will be RA into L. Okay, and the other one will be minus Ra into L, this has been considered, then 1 into this distance, and this remaining distance will be, when this distance is x, total is L, so remaining distance will be L minus x. So it will be 1 into L minus x equal to 0. From here I will get the value Ra equal to L minus x upon L. So this is how we get the reactions of Ra and Rb. Or you can simply consider the moment at A to be 0. When you got the value of Rb, simply put in this equation, when you will put the value of Rb here, you will get the value of Ra. Okay, now while making the influence line diagram, so you need to consider the boundary condition at A point. When you are at A point, the x value was 0. Okay, so at A point x value was 0. So when x equal to 0, then Ra equal to 1. When x will be 0, Ra will be 1, and then Rb will be x upon L, that means Rb will be 0 because x is 0. And when it will reach at B point, then x will be equal to L, and then Ra will be L minus L will be 0, that will be Ra will be 0, and Rb will be x upon L, so it will be L upon L means 1. So now while applying the boundary condition, you have got the value of Ra and Rb. Now for making ILD of Ra, simply apply first equation, Ra1, this 0. This is ILD for Ra, and when I am saying ILD for Rb, then you need to simply make this span. Rb value is 1 and this is 0. So this is ILD for Rb. So this is how you need to make influence line diagram for the reaction. Okay, that's it for today, but we will be discussing in other lectures that how we will be making the influence line diagram for the shear force and bending moment, and how we will make influence line diagram. Okay, thank you.